Let's practice writing and graphing solutions of inequalities. Keep in mind that each of these inequalities has an infinite number of solutions, and we're just going to be showing where the possible solutions are going to lay on a number line, and then list 3 possibilities. In the description box below, you can find a link to a free copy of this PDF as well as the answer key PDF as well if you find that helpful. Let's get into it. For number 1, we have x is greater than 4, so x could be any number that is going to be greater than 4. What we're going to do first is we are going to put the number 4 on our number line. I'm going to go ahead and do that in blue here. So put 4 right in the middle, that's the number we're talking about, and then just put some numbers above and below it, skip counting by the same value. So I'm going to go up by 4s here, I'm going to go to 8, and then go to 12. Feel free to skip count by something else. This will be 0, and then this would be negative 4. Now, since x is greater than 4, what we're going to do is we're going to put an open circle on 4. That means that x cannot equal 4. If we fill it in, then it can equal 4, but it is not filled in because x has to be greater than 4. Then let's go ahead and put an arrow in this direction. And also notice that the direction of the inequality symbol matches the direction of the arrow. So make sure that makes sense as well, as long as the variable's on the left side. Now, here's our graph. We also need to write 3 possible solutions. So let's go ahead and say that x could equal, I don't know, something like 4.1. X could also equal something like 5, and x could also equal something like 12.7, right? As long as you list 3 numbers that are greater than 4, you are good to go. For number 2, we have y is going to be less than negative 6. Let's go ahead and start by putting negative 6 in the center of this number line. Let's go ahead and put that right here. Let's go ahead and skip count. I'm going to choose to go by 3. So 3 higher is negative 3, 3 higher 0. 3 lower would be negative 9, and 3 lower would be negative 12. Let's go ahead and see here. It looks like we have a less than symbol, so let's go ahead and put an open circle again on this negative 6 this time, and y has to be less than negative 6, so that's any values that are to the left of it. So let's go ahead and draw an arrow. These are all the values that are less than negative 6. Now, what could y possibly be equal to? Well, what are some numbers that are less than negative 6? Well, some possibilities here are y could equal something like negative 6.1 if we want to go super close to it. We could also say something like negative 7 or something like negative 10. So these are just 3 possibilities of the infinite solutions that would make this inequality true. All right, let's check out number 3. For number 3, we have x is going to be greater than or equal to 9. So the number we're talking about here is 9. Let's put 9 right in the middle. And I'm just going to go ahead and put a 10 and 11, but feel free to skip by other numbers. I'll put an 8 and a 7 to the left of it. That's fine. Now we have a greater than or equal to symbol here, so we're actually going to fill in the circle that we put on 9 since it's allowed to equal 9. And we're saying that x is greater than or equal to 9, so we have equal to 9 because we filled it in, and then numbers that are greater than 9 are to the right. Now, what are some possibilities here? We could say x could equal 9 here, so I like to include it when it is possibly included here, like it's equal to or greater than. So we have 9, we could also say something like 15, we could also say something like, I don't know, 24. So just 3 possibilities. All right, for number 4, we have y is less than or equal to 0. Let's go ahead and put 0 because that's the number that we're talking about right in the middle. I'm going to go by 10s just because that's what I feel like jumping by. So let's go 0, 5, 10. And then to the left, we have negative 5 and negative 10. So y has to be less than or equal to 0. So since it's allowed to equal 0, I'm going to fill in on 0. And y has to be less than or equal to it. So that's towards the left in this direction. Okay, so what would be some possibilities here? Well, y could equal 0, right? So I'm going to go ahead and write that because I like including it when I can. Y could be equal to 0, but could also equal something like negative 1/2. I'm going to use a fraction here, or something like negative 4.7. Again, so decimals and fractions are all okay as well. For number 5, we have this inequality that x is greater than negative 5. So let's go ahead and put this negative 5 right in the middle. I'm going to jump by 3, so that's going to be negative 2 and then positive 1. And then I'm going to go down by 3, so that's going to be negative 8 and then negative 11. Now, x is greater than negative 5, so that doesn't include negative 5, so make sure that's an open circle. And let's put an arrow going to the right, because these are all the numbers that are greater than negative 5. So x could be equal to something like negative 4.5, right? That's greater than it. You could also say something like negative 2.1. You could also say something like 0, because that's bigger than negative 5. Moving on to number 6, we have this inequality of y is less than or equal to negative 3.5. Let's go ahead and put negative 3.5 right in the middle of our number line, and then let's just skip count by 1s maybe. So this would be negative 2.5 negative 1.5, so just going by 1. That means this would be negative 4.5 going smaller, and then negative 5.5 to go even smaller. Okay, so y has to be less than or equal to negative 3.5. So if it's allowed to equal negative 3.5, then fill it in because it includes it. And then anything less than that would be fair game as well, right? These are all numbers that are less than negative 3.5. So what could y potentially be? Well, y is allowed to be negative 3.5, so let's go ahead and include that one. But y could also be something like negative 7, and it could also equal something like negative 8 3/4, right? So any number that's less than negative 3.5 or equal to it would make this inequality true. Okay, let's check out number 7. For number 7, we have x is greater than or equal to 6.2. Let's take that 6.2 and put it right in the middle of our number line. I'm going to jump by, let's say, 0.4 because I feel like it. Up by 0.4, that's going to be 6.6, and up by another 0.4, that's going to be 7.0. Down by 0.4 is going to be 5.8, and down by another 0.4 is going to be 5.4. Okay, now x is allowed to be greater than or equal to 6.2, so we're going to fill in the circle on 6.2 because it's allowed to equal it, as well as anything greater than it. So I'm going to draw an arrow pointing to the right. So what could x possibly be equal to? Well, it's allowed to equal 6.2, so let's go ahead and include that. But it could also equal something like 6.7, as well as something like, I don't know, 9 1/3, right? So any numbers that are greater than 6.2 or equal to it are good. For 8, we see that y is less than 0.5, so anything less than 0.5 is good, not including it. So let's go ahead and put 0.5 in the middle, that's half. And I'm going to go up by 2's here, so that's half. If I go up by 2, that would be 2.5. I go up by 2 again, that's going to be 4.5. If I go down by 2, that's negative 1.5. And if I go down by 2 again, that's negative 3.5. Okay, so y is less than 0.5, so it's not allowed to equal 0.5. So put open circle that doesn't include it. And let's go ahead and put an arrow pointing to the left. So anything less than it would be okay. So we're going to go ahead and say that y could potentially be equal to, let's see, it could be 0.4 or 0.49. Let's go really close to it, okay? Then we could also say something like 0. 0 is smaller than a half, right? And we could also say anything negative, like negative 4.9, okay? Again, I'm not saying that our variables have to be equal to these 3 numbers. I'm just saying these are 3 possibilities that would make it true. Again, there are infinite solutions or infinite possibilities. I'm just giving 3 examples. Okay, so feel free to change yours to other things. For number 9, we have x is greater than or equal to negative 7. So that's going to be our inequality we're talking about. It's negative 7 we're talking about, so that's going to go in the middle. I'm going to jump by 5's here, so if I jump up by 5, that's negative 2. If I jump up by 5, that's going to be a positive 3. Down by 5, it's negative 12, and down by 5 is negative 17. Now, if x is greater than or equal to negative 7, that should include negative 7 because it's or equal to, so fill it in. And then draw an arrow to the right because it's anything greater than or equal to it. So we can say that x could equal negative 7, that's fine. We could also say that x could be something like negative 6, that's also fine. Or x could be equal to 0, because that's greater than negative 7. For number 10, we see that x is less than negative 8.3. Let's put negative 8.3 right in the middle of our number line. Let's jump by 0.7s. Okay, so if I go 0.7 bigger, that's going to be negative 7.6. And if I go 0.7 bigger, that's going to be negative 6.9. If I go 0.7 smaller, that's going to be negative 9.0. And if I go 0.7 smaller than that, that's going to be negative 9.7. Okay, so x is less than negative 8.3, so it can't include it, right? So put an open circle. And let's go ahead and say that anything less than that would make it true. So anything to the left here. Okay, so what are some potential things that x could equal? Well, x could potentially equal something like negative 8.31. That's slightly smaller, so that works, right? Negative 9.4. We could also say something like negative 25, right? That's definitely smaller than negative 8.3. Moving on to number 11, we see that x is going to be less than or equal to negative 5.4. So let's put negative 5.4 right in the middle here. And then let's maybe jump by 0.4s. Okay, so jumping up by 0.4, that's going to be negative 5.0. And if I jump up a 0.4 again, that's going to be negative 4.6. If I go smaller, it's going to be negative 5.8. If I go even smaller, it's going to be negative 6.2. Okay, so x is going to be less than or equal to negative 5.4, so it's allowed to equal it. So I'm going to fill this circle in on negative 5.4 and then draw an arrow to the left because it's less than or equal to this number. So what could x equal? Well, it can definitely equal negative 5.4, so again, I like including that one. It could equal negative 5.7, and then it could equal negative 18. Okay, just a random number that's smaller than negative 5.4. One final one here, we have that x is going to be greater than 4, so a nice easy whole number, integer here. Let's put 4 in the middle. I'm going to jump by 10s here, so let's say 14, let's say 24. Let's drop 10, that would be negative 6, and drop another 10, that would be negative 16. And so x has to be greater than 4, so it can't equal 4, so put an open circle, and let's put an arrow to the right here. Those are numbers that are greater than 4, so we can say here that x could be something like, 4.5, that's bigger than 4, right? You could also say something like 15, and you could also say something like, 25.7, right? Just a random number there. So there you have 12 different practice problems on looking at an inequality and graphing it on a number line, and also writing 3 possible solutions. So if you found it helpful, please consider giving it a like and sharing with a friend who might find it helpful as well. And as always, keep up the great work that you're already doing, and I'll see you in the next one.